Okay. Okay. So, first of all, you guys need to remember that we got to learn how to define moment. Moment is basically defined as force applied times perpendicular distance about a pivot. So that's the definition. Now, moment's formula would be m equals to force times the perpendicular distance. The SI units for moments are Newton meters. Okay, and then it's you guys need to remember it's a vector quantity. The reason why it is a vector quantity, because a turning effect can either be this way, which is clockwise, or it could be this way, which is anti-clockwise. Now, a lot of things basically use moments, and we got to understand how we do it. So first of all, let's talk about a door. So when you look at the door from the top, you will see at the end of the door there is a hinge which acts like a pivot, and then if you apply a force like this at a distance which is this one, so you are gonna get the moment which will be equal to force times distance, and it will cause it to turn about this pivot in anti-clockwise. Is it clear? Even small points in our hand or arm or whatever works like this. Like for example, our arm looks like this, right? So this, our elbow, basically plays a role like a pivot, because then when we pick something up, right, we lift something up, we apply a force which is perpendicular to the pivot, and that's why we can move our arm and lift things. Now what we need to understand is that suppose we take the example of a door. This is the hinge, and there are a couple of forces which are given. A force from here, let's call this F1. A force from this point, let's call this F2. A force from here, which is F3. So what you need to understand is that F1, let's say the distance of F1 is D1, and distance of F2 till the pivot is D2, and the same distance for F3. So F1 will have a smaller turning effect. The reason is that because the distance is small. So if the distance is small, it's very hard to turn stuff. So you basically want to have a longer distance. That's why the doorknob is placed at the end of the door, not where the hinges, right? F2 will have the maximum moment because it has the largest distance. Also, the force is perpendicular to the pivot. So force must always be perpendicular, okay, to the, not the pivot, the distance. That's the condition. Now, F3, however, has zero moment because the force is not perpendicular to the distance. So basically you're pulling the door in the same way as distance, so it's not going to turn at all. Is it clear, everybody? Okay, now, so then we can move to the principle of moments, which states that in rotational equilibrium, when we say rotational equilibrium, it means that neither it is going anti-clockwise nor clockwise. The sum of clockwise moments is equal to the sum of anti-clockwise moments. Is it clear?
Yes.
Now, suppose you have a body like this, you got a pivot, and then you have one person sitting right here, one person sitting right here. His distance to pivot is 2 meters and his distance to pivot is 1 meter. His weight is 800 newtons and his weight is unknown, W, right? And we want to find it. So first of all, you would always look at the direction it will turn. So about W, about this pivot, it will try to turn it this way, which is the clockwise, and this force will try to turn it this way, which is anti-clockwise. Now, according to the principal moments, if it is an equilibrium, then anti-clockwise moments is equal to clockwise moments. So it will be 800 times 2. This will be W times 1. So the weight of the other person should be 1600.
1600.
Yes, for it to balance, right? Very good. Now, similarly, suppose they have this pivot, and this time there is one person here, one person here, and one person here. So they have given these distances. This is 2 meter, this is 1 meter, this is 1 meter. 1600 newtons, 800 newtons, and we would like to know what is his weight. So for this one, you should remember that one by one, this person is going to turn it this way, which is anti-clockwise, clockwise, and this person also this way, and this person anti-clockwise. Now we gotta do anti-clockwise equals to clockwise. So anti-clockwise would be 1600 times 2, then clockwise would be 800 times 1 plus W times, now the thing you guys need to always remember is the distance is taken from the force till the pivot, so you will write 2, not 1. Is it clear?
Yes.
So this will make it 3200. This is 8800 plus 2W. You subtract this, 3200 minus 800, and then divide by 2. So W,
1200.
yes, 1200. Very good. Like that. Alright, that's how you're gonna deal with this. Now the third example is, this time you got 2 pivots instead of 1. So A and B. And okay, before this I just want to, in fact let's do it afterwards. Before that I just want to tell you about the conditions of equilibrium. So you need to remember that an object is said to be in equilibrium if, number one, sum of all forces is equal to 0, which also means that there is no resultant force. And the other thing is, sum of all moments are equal to 0. So which means that clockwise moments sum should be equal to sum of anti-clockwise moments. Is it clear, everybody? That's the two conditions of equilibrium. Now looking at this then, we should remember, like for the previous example, if this force that we found out to be 1600, these forces are down, which means the pivot is going to put an upward force which is equal to 2400 in total, so that it is balanced in terms of forces as well. Is it clear? Both Alice?
So can you please repeat?
Yes. You see, the upward forces should be equal to the downward forces, because not only the moment should be in, say, balanced, but forces should be. So upward force was, say, the pivot's reaction, right? So that's R. And the downward forces are 1600 plus 800, which goes to 2400. So pivot is basically opposing it by this much force. Is it clear? Any questions? Please let me know. Now, about this one, if we do upward equals to downward, so there is a force on this as well, which is R. Now downward forces are 1600 plus 800 plus 1200. So the total would be 3600. Is it clear? So the pivot will be feeling this much force because of all that force that's down. Any questions? Okay. Now, this is important because if there are two pivots, say a pivot here, say A and B, right? So suppose the weight of this beam itself is 1600 newtons, and there is a box placed here which has its own weight as 800 newtons. Now they've given the distances. They say, okay, from this to this it is 2 meters, from this to this it is 1 meter, from this to this it is 1 meter. Is it clear? Now they say that the pivot are having a reaction force at A, and some of the force is being lifted by B as well. So they want you to find these two. Any questions? Ali and Hussain? Ali and Hussain?
No.
Now what you do is...
Sir,
Yes?
I just joined. I didn't realize the time. I'm sorry.
Okay. Now, please watch the recording then, okay? I'll post it.
Sure.
Now check this out. Suppose if this is exactly in the middle, right? This force. So it will be divided equally, which means half of it would be lifted by this and half of it would be lifted by this. Is it clear? But then there is the other issue about the 800 force, which is closer to B and less close to A, which means B will have a greater effect, right? So what will we do? We'll do a simple ratio method. So you guys need to understand that B is 1 meter from the force and the other one ratio is 3 meter. Is it clear? If you look at it, this whole distance till the force is 3 meters, and that's just 1 meter. Now to do this, just remember this. So you always add these two. So, and apply the inverse ratio. What I mean by this is that if I say 1 on top and the total number is 4 multiplied by 800, so this is going to be 200, right? Is it clear? Which means that this force will be transferred to A. Why? Because A is away from this. So I'll add 200 with this. And for the other one, 3 is the other number for the ratio, and total ratio is 4 times 800. So that's going to be 600. So the other one is going to be transferred here. So total, this one is going to have 1000 newtons reaction, and this one will have 1400. Is it clear, everybody?
Yes, sir.
Just a bit tricky, but you should remember, just apply inverse ratio. So the greater number, the greater force will be where the object is closer to that pivot, and the lesser force will be where the object is away from. Is it clear? All right, now considering this, then you should remember that there's something called center of gravity. Now, center of gravity is basically defined as the point where all the weight of a body appears to act. Okay. Now, what it means is, suppose you have known shapes like a square, a rectangle, a triangle, and a circle. So you make line of symmetries. So wherever the line of symmetries basically intersect, that is the point where all the weight is going to act, and that's called the center of gravity. For this one, it will be easier as well, because you can easily make its regular shapes. You can make center of gravities. So this will be like line of symmetries, this will be the weight, and this will be center of gravity right here. For a triangle, you can make them like this from the vertices where all meet. That would be the center of gravity. And for a circle, you can just cut the circle from half, and that would be the weight. Is it clear, everybody? Can you please draw this?
Yes, sir.
Okay. All right. What you want to do is, we're gonna stop the class here. Okay. and we're gonna complete the chapter in the next class, and then we'll do the worksheet. Is it clear? Is you guys have, I mean, copied everything that we did today? Both Ali's and Sam?
Sir, could you go to the top so I can screenshot it?
Yes.
Oh, yeah, thank you.
All right. Okay. I will see you then.
Yes.
Bye. Have a nice day.
Allah Hafiz, sir.
Bye. Thank you.